Hi everyone, Troy Richardson here. In this presentation we're diving into another crucial aspect of ziplining, the mathematics for arrival speeds. Because ziplining is not all about the thrill, it's about safely stopping your zipliner. And if you know the arrival speeds, you'll know whether you need an emergency brake or not if you're following the standards. Where this video fits in emergency brake training under zipline arrival speed is in the mathematics section number 3. The 5 quiz questions we gave previously in our pretest will be answered during this presentation. First one is, what type of math can find zipline speeds? What variables help you find the zipline speeds? Which variable can change speeds in the impact velocity formula? And how to convert feet to meters? And we'll also address why variables are so important. First, what type of math can we use to find zipline speeds? Well, here's the impact formula. It's a simple formula, a little bit of algebra, but the answers are basic algebra equations calculates zipline. Trigonometry is also a way we can estimate. Calculus and thermodynamics are complex scenarios to estimate arrival speeds, and algebraic equations make it simple to determine arrival speed. What variables help you find the speed of your zipline? Well, the variables include calculating speeds from the length, which you can do distance over time, but that one has some problems. Impact velocity variables include gravity and height, but the units must match. Zipliner mass and temperature affect zipline speeds considerably, but we will not be discussing that section in this presentation. Frictional forces such as wind and trolley speed, trolleys can slow down because of bearings, also affect the zipline. Which variable changes the speed in our impact velocity formula? Well, the answers are the variables for height difference between platforms. That's how you can an estimate of your speed. Gravity variable has its units in feet or meters. Whatever units your height measurement is, your gravity units need to be the same. Temperature variables change the length of your zipline, but we won't dive into that in this presentation. Height between platforms is crucial for the math that we will be doing. So how do we convert feet to meters? Well, the answers are pretty simple. To convert feet to meters, all you have to do is times 0.305 times the amount of meters that you have, and that'll give you your number of feet. One thing that you can do too is you can multiply the number of meters by 0.35 to obtain the length in feet. And also 3.3 feet equals 1 meter. Use online conversion tools or reference tools. They also help to convert feet to meters or meters to feet. So let's just do a simple conversion here. So if we convert 40 feet to meters, what we're going to do is we're going to times 40 times this constant, which is a 0.35, and that gives us an answer of 12.3. The units must match in all of our formulas. The height formula that we're going to use is in feet because we got sea level elevations, but we could use gravity units of feet per second to find the answer. For now, we'll just stick with converting the height of feet into meters. 40 feet equals 12.3 meters. Then we'll put it in the impact velocity formula equation, and it ends up calculating as 15.1 meters per second. So why are the variable units so important? Well, the answers include the units must match to solve this math correctly, because 1 foot equals 0.305 meters. They're not the same. Meters are about a third of 1 foot. The units are considerably different, and so you've got to match the units for your equation to get your accuracy. Let's do a quick review of the variables in the impact formula. First up is V, the arrival speed answer that we're looking for when we have an H that is known. And so this is the side of the equation we're solving for. Now let's look at the square root symbol. Square root symbol may be different. You may see something similar, you may see something that has a line across the top. And more review, we'll talk about gravity. The gravity, or the G value in the formula, is very important. Gravity after the number 2 represents 9.8 or 32 feet per second. Remember, the units must match the height variables. That is critical. And now let's look at the height, which is the height difference between platforms in our formula. We know that H is the number we are looking for to figure out what V equals. H in the formula follows the gravity constant, which is either 9.8 meters per second or 32 feet per second. So your platform height difference, let's talk about that. The way to obtain this is to use a GPS to capture your platform's height based on sea level elevations, and it'll be in feet. other parts of the world be in meters. So what you want to do is find the upper platform height, then subtract it from the lower platform height, which in our equation equals 40 feet. There's some simple math here that I will show you this video that you can watch how they evaluate and find the variables for a free fall equation, which is very similar to what we're doing here. What you'll be watching here is a simple free fall demonstration to find out what the V final is, or the final speed, in a free fall equation, very similar to the impact velocity equation. So let's watch this right now.
In this video, I'm going to cover another free fall type problem. So our problem for today is a ball is dropped from a 20-meter building. How fast is the ball traveling just before it hits the ground? So as always, we should start with our known and our unknowns. We start off in the problem, it tells us that the ball is dropped. So that in itself is a known value. When things are being dropped, that tells us that the initial velocity is 0 meters per second. It's dropped from a 20-meter building, so that's going to give us our height, which is our delta y. And since it's falling downwards, we're going to attach a negative value to it. As the ball falls, it falls in free fall. We know that the acceleration in free fall is that of gravity, so negative 9.8 meters per second squared. And then our unknown value here, since it's asking how fast just before it hits the ground, we are trying to find VF.
And VF is exactly what we're looking for between platforms with the impact velocity formula. Last but not least, there are 3 math resources. You can pause and capture the information. Thank you. We are finished with this math section, and we will move on to the next presentation.